Good evening, all. Students, I request please inform your friends to join the session. It is already 7:06, so kindly ask your friends to join the session as soon as possible. Roshit sir, good evening.
Yeah, good evening, Sushmita.
You can start the sessions.
Sure. Students, please ask your friends to join fast. We will start the session in next 2 more minutes. So please put in your WhatsApp groups or somewhere and please make your friends to join fast. While I set my whiteboard, please ask your friends to join fast. Okay, very good evening, everyone. I see still only 73 participants. Please ask your friends to join fast while I start the session. Good evening, everyone. Can I get a quick heads up in the chat box? Good evening, Suash. Suyash. Good evening, Snehal. How are you all doing? Is the assignment done? Yes. Good evening, Niharika. Good evening, Kajal. Good evening, Suresh. Good evening, Jinat. Good evening, Varshita. Good evening, Kanak. Good evening, Maud. Good evening, Vinit. Maud, can you put your name? Can you rename to your name? Good evening, Sangam. Good evening, Anand. Okay. So, what we have discussed in the last class? What we have discussed in the last class? Good evening, Anurag. Welcome. So, what we have discussed in the last class? We went with the merge sort, right? We went with the merge sort. We again discussed the kick sort and then we went with the merge sort. Okay. So, how does merge sort works? How does merge sort works? So basically, if I have the elements like 2, 5, 10, yeah, 2, 15, 10, and then 9, and then 6, and then 75. Suppose these elements are there. In this, what you need to do? What you need to do? So basically 0, 1, 2, 3, 4, 5, right? So you will be calculating the low plus I, which is nothing but a lower bound plus upper bound divided by 2, right? Lower bound plus upper bound, you will divide it by 2. Yes, divide up to one element subarray, merge them with sorting. Yes. So we will divide this array in such a way that there exists only one array. Okay, there exists only one subarray. Okay, one element subarray until we get the one element subarray, and then we are going to merge it. Then we are going to start merging it. Okay, then we are going to apply the merging algorithm. So basically, how you will find the mid element for division, LB plus UB by 2, right? So basically 0 plus pi by 2, which is nothing but 2.5. We can take this as your mid element. Okay. Now what you will do until this point, you will take it up here. Okay, 2, 5, and then 10. Okay, then this one 9, 6, and 75. You will again divide. Again here also you will find out the middleman 0, 1, and 2. 2 by 3, 0 plus 2, 2 by 3, which is nothing but 2 by 2, which is nothing but 1. So this will become the mid element. So again what you will do, you will merge this 2, 5, and then 10. Okay, then here 9, 6, and then 75. Okay, then again you will merge it up 9, 6, and then 75. Okay, and then this will be anyway 75 itself. Now what you will do, you will start the merging here. Okay, you will start the merging here. So 2, 5 again, it should be merged, right? Yeah. So here We'll start the merging again. Okay, 2 and 5, it will be here. Okay, 2 and 5. In the temporary array, we'll put it up, right? We'll take it this as a left array, this as your right array. Okay, then 2 and then 5. And then here we'll again this compare this sublist with this sublist for merging. So what will happen now? In this array, it will be coming at the last. Okay, 2, 5, 10. Okay, here again 6 will come first, then 9 will come first. Okay, and then 75 will be merged. And then 75 will be merged. There are only 6 elements. Okay, 1, 2, 3, 4, 5, 6. Okay, then what we are doing here, we are merging finally into a final temp array, final result array. Okay, so what we will do basically, we will consider this as your left array, this as your right array. Okay, and then we will start I, and then we'll take the size of the array for merging. So basically, in this case, if you see, what will be the size of the array if you wanted to merge these three? How much size is required? So basically, for the temporary array, how much size is required? Here it is 1. Like upper bound is how much? 2. Okay. Then lower bound is 0. 2 minus 0. Okay. 2 minus 0 plus 1. The size of the array should be 3. Right? The size of the array should be 3. So what is the formula you can apply to find out the size of your temporary array? Upper bound minus lower bound plus 1. Okay, upper bound plus lower bound plus 1. So means now the temporary array size will be 3. In this case, if you see, what is the size of this array? It is 3 and 4, right? So the 3 is lower bound, upper bound is 5 in this case. You are merging 3 and 5. 3 and 5 sub array. So 5 minus 3, which is nothing but 2. 2 plus 1, which is nothing but 3 elements here again. Okay, now you see here this is 0 array and this is your fifth array, right? So this is your fifth array. So 5 minus 0, which is nothing but 5 plus 1, which is nothing but 6. Okay, so the size of the array will be 6. 0, 1, 2, 3, 4, 5. Okay, so now this is your 0, 1, 2, 3, 4, 5. So I will be at zeroth position of lower bound, which is nothing but lower bound. And here we'll be taking the j. Okay, we'll be taking the j, and this k will be going to the zeroth position. Okay, now you will compare I with the j. Okay, left of I with right of j. 2 is less than 6 or greater than 6. 2 is less than 6 or greater than 6. 2 is less than 6. So in this case, from the left array, this element will be coming, and then I pointer, I will increment. I pointer, I will increment. Then K pointer also I will increment. Then again, I will compare 5 with 6. 5 is again lesser than 6. Then in this case, what I need to do? Again, I need to move the I pointer as well as I will put this here, and then I will move the K pointer. Okay. Then again, 10 is compared with 6. 10 is lesser than 6. No, false, right? So 6 is lesser than 10, right? So in this case, the 6 will be coming here. Okay, then I will move the j pointer. Okay, then I will again move the k pointer. Then again, 10 is compared with 9. 10 is compared with 9. 10 is lesser than 9. No. So in that case, I will move the j pointer and I will put the 9 here, and then I will move the k pointer. Okay. Again, 10 is compared with 75. This is lesser, right? So in this case, I will put the L of I, and then I will increment the I. Okay. Now I has exceeded the your mid. Okay. I has exceeded the mid. Then in this case, what you need to do, if I has exceeded the mid, then in this case, you will just put all the remaining elements that were there here until j less than upper bound. J less than or equal to upper bound. Until this point, you will put all the elements within the array. So what is remaining only? That is 75 is remaining. That I'll be placing within this array. of k. Okay, now this will be the sorted array. Are we clear until this point? Yes. So if you see the algorithm, now, are we clear with this merging? Yes. Are we clear with this merging, everyone? Yes. Okay. So first I'm taking this array elements 8, 6, 15, 19, 7, 9, 5. Okay. 8, 6, 15, 19, 7, 9, 5. And then merge sort of sort I'm calling this array with this array. I'm calling the function and 0 as your lower bound. Upper bound is array dot length minus 1. Okay. Upper bound is array dot length minus 1. Okay. Then this will be called now. So let me put this in a stack. Okay, ignore my drawing. Okay. I am putting merge sort. I'm calling merge sort, right? So array comma 0 comma what is the length? 1, 2, 3, 4, 5, 6, which is nothing but 5 will be the upper bound. Okay. 1, 2, 3, 4, 5, 6. Okay. And this will be called. Now what you are checking? 0 less than 5. Condition is true, right? So it will come inside. Mid will be 0 plus 5 by 2, which is nothing but 2.5, which is nothing but 2. Since it is an integer, it will be 2. So here now merge sort. Merge sort of array comma. What I am doing? Merge sort of array comma. I am calling LB. LB in the sense your 0. 0 comma mid. 0 comma mid. So what will happen now? 0 to 0 to 2 I am calling. Okay. 0 to 2 I am calling. It will go here again. It will go to the merge sort again. Then again it will check 0 is less than 2. Condition is true. 0 is less than 2. Condition is true. So in this case, it will again come inside and then again it will take mid is equal to 0 plus 2 by 2. 0 plus 2 by 2, which is nothing but 1. Okay. 0 plus 2 by 2, which is nothing but 1. So what will happen now? Array comma 0 comma 1. Okay, array comma 0 comma 1. Okay, then again it will go and again it will see 0 less than 1. 0 less than 1. Again it will come inside and what will happen now? Mid 0 plus 1 by 2. 0 plus 1 by 2, which is nothing but 0 plus 1 by 2, which is nothing but 0.5, and that will be taken as 0. Array comma 0 comma 0. So what has happened now? 8, 6, 15 is one sublist. 8, 6 is one sublist. 8 is one sublist. It has divided the left off completely. Through this recursive call, it has divided the left off completely. Okay. Now what will happen? Again 0 to 0, right? It will go back again. Okay. It will go back again. 0 to 0. Okay, 0. It will be 0. The upper bound will be 0. 0 less than 0. Condition is true or false? 0 less than 0. Condition is true or false? Condition is false. In that case, what will happen? It will not go inside. Okay, it will not go inside. What will happen? What will happen? It will be coming here. Okay, it will come here and then this this function will be done. This function will be done. When this function is done, what will happen? It will return to the previous call. It will return to the previous call. Previous call is not totally completed. At this step only it got stuck. Okay, at this step only it went back. So what will happen now? Again this will be called now. This previous call we will be going to the next line. Okay. So what will happen now? Mid plus 1. Like mid is how much in this case? 0 plus 1 by 2, which is 0 plus 1 by 2, which is nothing but 0.5, 0 plus 1 by 2, which is nothing but 0, right? 0 plus 1, which is nothing but 1, right? So what will happen now? Mid plus 1, which is nothing but 1, comma, upper bound is also 1. Upper bound is also 1. It will go again, it will again go to the top. It will again go to the top with this. So 1 comma 1. So which is nothing but 1 comma 1, right? Our lower bound is also 1, upper bound is also 1. So 6 will be taken up. Yeah. So again it will go back. It will again go to this array. Okay. Now 0 less 1 less than 1. Condition is false. So what will happen now? This will be executed. It will not come here. This function call will be over. It will again go back to the previous. It will again go back to the previous. And again it will execute this line merging. Merging of array, and then LB is nothing but 0. Mid is nothing but mid is also 0, right? Mid is also 0. Upper bound is 1. Means this one. 8 and 6. 0 to 1. This will be given for merging. This will be given for merging to the top end. Okay, this will be given for merging to the, this will be given for merging to the, okay, this will be given merging to the top. Okay, what will be given? 0 and 1. 0 to 1. So what will happen now? Array, and then 0, and then mid will be mid will be how much? It will be also 0, and int will be 1. Okay, int will be 1. So what will happen now in the merge? This function will be called, right? Here it will be merge, comma. You will have your array comma and 0 comma 0 comma 1. Okay, so int I is equal to 0, int j is equal to 0 plus 1, which is nothing but 0, and then here it is 1. Okay, k is equal to 0. Now what will happen? Temp is equal to 1 minus 0. 1 minus 0, which is nothing but 1. 1 plus 1, which is nothing but 2. So there will be two places in this temp array. There will be two places in this temp array, and then I less than or equal to mid. 0 less than or equal to 0. Condition is true. And 1 less than or equal to 1 less than, and 1 less than or equal to 1. Condition is also true. It will come inside. Okay, it will come inside. So array of I is equal to array of I less than or equal to array of j. So it is 10 and 15, right? If array of I is 10, and array of j is 15. So if it is less than, what will happen? 10 will be coming and sitting inside the k. So k is 0, right? And then k plus plus I am doing, k will be moving to the next pointer. Okay, and then it will again go to the top. It will again go to the top. We are also doing the I plus plus. I will be 1 also. I will be 1. So now 1 less than or equal to 0. Condition is 1 less than or equal to 0. Condition is true. Condition is false. Okay, 1 less than or equal to 0. Condition is false. It will not go inside. It will go to the next one. I less than or equal to mid. 0 less than or equal to mid. 0 like 1 less than or equal to mid. Condition is false. And then 1 less than or equal to 1. 1 less than or equal to 1, condition is true. So what will happen now? Temp of k plus plus. Temp of k plus plus means at this position. So temp of k, this is post increment. So what will happen? Temp of k. Temp of k will be array of j. Array of j in the sense how much? 15. 15 will be placed here, and then j plus plus k plus plus. Right? So k will be pointing to k will be pointing to 0, 1 and 2, and whereas j will be pointing to 2. So now again it will come 1 less than like 2 less than or equal to 1. Condition is false. Now it will come back again. we are we are putting all the arrays back to the primary array, that is our array. Our array. I'm putting back into the our array. I'm copying all the elements from the temp array and I'm putting it here on the our array, that is array. From temporary to our array, I'm copying it up. I'm copying it up here. Okay. So for that reason, again the k will be 0. And then for I is equal, for int x is equal to LB, x less than or equal to upper bound means until 0 to 1. Until 0 to 1, I will be copying all the elements from the temporary array to our array 10, 9, 15. Okay, array of x is equal to temp of k plus plus. Are we clear? Are we clear with this iteration? Yes. Yes. So this is how, again, what will happen now? This function call will be executed and then it will come back to the previous call. It will come back to the previous call, and now here what will happen? Array of 0. It will again come back to the previous call, and if you can see, so now what will happen? This merge will be executed and then this function is done. This is also done. So in this case, this function is totally done. This function is totally done. It will return back to the previous one again. It will return back to the previous one again. Again, it will start the next thing. Again, it will start the merge sort of next one and then merging of next sub array. So like this until end of the array, it will keep on doing. It will keep on doing until end of the array. Okay. So this is how it will work. This is how it will work. Okay. So I hope it is clear. Okay. So let me clear my drawings. So yesterday what mistake we have done means we have copied the entire array as a temporary array. Okay, we have copied the entire array as a temporary array. Okay, entire array means length of the array as a temporary array. Because of that we are getting the zeros yesterday. Yes, we are using the original array for sorting. We are not copying from the temporary array to the common array. Okay, so that was a mistake yesterday we were doing. For each merge, we were not doing the copying back from temporary array to the actual array. Okay, actual array, because we should, because merge will be like sub array wise, not whole array will be merged at once, right? Not whole array will be merged at once. Merging will be sub array. Okay, so for that reason yesterday we are getting the elements somewhere and zeros are there. Okay, so on that note, sorting algorithms were done. Okay, I have taken three like almost 3 sessions on sorting. Okay, I hope you are clear, because this is most important asked in every interview. Every interview, these sorting algorithms will be asked, and you should take forward. This sorting is used in almost all lead code problems. Okay, almost all lead code problems, you will be mostly using the sorting algorithms, this kind of algorithms. Okay, so what is the time complexity of this? What is the time complexity of this? Time complexity of your merge sort? Okay, what is the time complexity of this? No, it is not n log n. How it is n log n? Here we are doing any of things. Huh? So here you see, we are merging like the division, you can leave it up, but merging if you take, this is off of the array and this is off of the array, right? This is off of the array and this is off of the array. If you consider this size as your big O of m, okay, if you consider this as your big O of n, we are putting everything in one array, right? So the time complexity will be big O of m plus n. Okay, big O of m plus n. It will be the time complexity of your merge sort. Yes, you are correct. We are considering offer. Like you are thinking like binary search. Since I have taken the mid element, you are thinking like binary search. In the binary search, what we are doing, instead of going along the whole array, we were only taking the off part of the array. Hmm. We were taking only the off part of the array. We are not traversing this off part. In the case of your binary search, we are only traversing the off of the part. That's it. Okay. In binary search, we are not traversing the n. So because of that reason, we are taking as log n. Since we are only like a log, like in that also, in this off also, we are not sorting the off part also. Again, we are to taking over the off part in this also. But here if you see, we are considering a whole array. Here we are dividing, that's it. But we are not, we are considering this part also, we are considering this part also. So in this case, it will be, we are in merging, it will be like this also we are doing, this also we are doing, right? So because of the reason, whole array we are sorting. So if you consider this as your big O of n, this is your big O of n, then the count complexity will be big O of n plus n. Okay, left subarray and right subarray. We are doing the merging of both. Okay. Okay. So this is how the sorting algorithms will work. Let's go into the next. Let's start our linear data structures. Okay, linear data structures. That is the first one is linked list. We are done with your arrays. Next one is your linked list. Okay, so what is linked list? What is linked list? So basically you will have your node, right? You will consider, like in the case of your Java, you will consider as node object. Okay, you will consider as each one as node object, each element as node object, and this node object will have three parts, will have two parts, right? So we have our data part, we have our address part. Okay, basically the address of your next node, address of our next node. Okay, address of our next node. So basically what will happen in the case of your array, the data will be contiguous. Data will be contiguous in the sense, suppose like 15 is there here, 12 is there, 11 is there, some 9, 8. Okay, suppose this is stored like this, right? Suppose this location is some 2000, then this should have be contiguous 2001, 2002, 2003. The contiguous memory allocation should be there in the case of your RAM. In the RAM, the contiguous memory allocation should be there for your array. But what is the advantage of your linked list is, what is the advantage of your linked list? You can have, you can have random. You can have random. So here it can be, here it can be, here it can be. Suppose if you consider this also as RAM, here it can be, here it can be. Okay, so if suppose this is your 2500, if this is your 2000, it can be at 10,000, this can be at 15,000, this can be at 500, this location can be at 700. Addresses I'm talking about, address locations. Okay, now I'm writing the same 15, 12, 11, 9, 8. What will happen now? What will happen now? The next node, the next pointer will be storing the address of the this one. So it will be storing the 700. Okay. This will be storing the 700. And then this will store the 500, right? 500 it will store. And this it will store the 1000. 10,000, huh? 10,000. Okay. This will store like this. And then this will be storing the 15,000. Okay. This will be pointing to the 15,000. So like that, here if you observe in the case of your linked list, it is randomly arranged. In the case of your addresses, random, you can arrange anywhere in the no need of contiguous allocation. No need of contiguous allocation in RAM. Okay, no need of contiguous allocation in RAM. Okay, we can directly connect it through a link. We can directly connect it to a next node link. Okay, and this is one of the advantage of your linked list over array. And you need not to declare the fixed size here in the case of your array. you will declare it as fixed size. But here you need not to declare the fixed size, it can be dynamic, because this will be anyways pointing to the null. This will be anyways pointing to the null, and here also this will be pointing to the null. So you can directly attach to this null only, you will attach another node. Okay, then this will be pointing to null. Means you can dynamically add the elements, you can dynamically add your node objects, you can dynamically add your data, right? So then like fix dynamic size, this is another advantage. Okay, dynamic size. And mm, okay, so basically the first node in the linked list will considered as your head node, the last node in the linked list will be considered as your tail node. Okay, the last node in the linked list will be considered as your tail node. So head to tail, head to tail node. Okay, so this is how it will work. Okay, so basically like operations inside your any data structure, you perform these operations, right? From now on, any data structure that you take, what operations will perform? Basically, you will perform insertion, you will perform deletion, you will perform traversing, basically you perform search operation, you will perform updation operation. I can also consider this search as your read. I can also consider it as traverse operation. Okay. So in the case of your linked list insertion, I can do it in big O of 1 itself. Okay, in big O of 1 itself I can do the insertion. Okay, because directly the last tail node I need to connect to the next node, right? So insertion can be done in constant time. Whereas deletion, if you come, deletion, if you wanted to delete at the end or at the beginning, you can do it in the big O of 1. But if you wanted to do it in the middle, then you need to traverse, right? You need to traverse over it. So because of that, it will be big O of n. Okay, in the worst case, it can be big O of n. Okay, then searching, reading, or traversing, searching also big O of n itself, and updation also, like you need to traverse, right? So it will be big O of n itself. Okay, so these were the operations we will be doing inside your linked list. So there are like types of linked list. So types, so what types are there? You will have your singly linked list, you will have your doubly linked list, you will have your circular linked list, you will have your doubly circular linked list. Okay, so singly linked list is nothing but, this is nothing but a single linked list, means each node will have only one node. Okay, each node will have only one single node connected, each node will be connected to the single node. Okay, in the case of your doubly linked list, in the case of your doubly linked list, each node is connected to each other. Okay, each node is connected to each other like your train format. Okay, you will have your three parts, it is divided into three parts. The second part is your data part. The first will be pointing to the previous node, the next will be pointing to the next node, and then this is also same, the next will be pointing to the next node, the previous will be here, in this case it is null. Okay, then here also it will be same. Okay, previous will be pointing to the previous and the next will be null. Okay, here it is data part. Okay, so this is how the doubly linked list will happen, and the allocation in the case of your RAM is random only. Okay, you can arrange it anywhere. Okay, and then if you can see your circular linked list in the sense, simply the last node is pointed to null here, right? That will be pointed to the previous node. The last node is pointed to null here, right? That will be pointed to the your previous node. So this is nothing but your circular linked list. Okay, circular or doubly circular linked list is same. The last node will be connected to the previous node. It will not be pointing to the null. It will be in the form of a loop form. Okay. So are we clear until this point? Yes. Are we clear until this point? Okay. So let us implement our linked list to code. So basically in Java, you need not implement also. You need not implement the linked list by your own. You can directly take the implementation already done. The ready-made implementation is already done inside your, the ready-made implementation is already done. Done inside your, okay, inside your java.util.collections. Okay, in this package, you will have a linked list class. Okay, java.util.list or linked list. In those collections interface, okay, in the collections interface, you will have your, in the collection interface, you will have your list, your queue implementation also will be there. You will have your, you will have your, okay, you will have your set implementation as well. In this, the other implementations will also be there in the case of your Java. Okay, so if you can see here, you'll have your ready-made implementations here. Here, you will have all the methods here and inserting the node. And if you can see the add implementation, uh, okay, we can see the node implementation also. See, node of previous, node of next, data, and then you will have your constructor, and inside this you will have your the other things, right? In the list class, this implementation is already there for your node. Okay, and in the linked list also, if you can see, for if you go to the add update, okay, add method, if you can see, okay, so add first, okay, add first, add, okay, so see here, link last. In this method, they have written the implementation already. Okay, they have written the implementation already. And then add first, add last, like that. All the methods were there. Like if you can see, remove for your deletion, remove first, remove last, and then contains, then remove, then add all. So get set is for your updating, get is for your reading. Okay, so these are all the methods that were there already readily written. So that is the advantage of your Java over other languages. Other languages, this is the advantage. Okay, so this is how you can get the implementation ready in the case of your Java. But since this is a DSA class, I need to definitely go through the implementation as well. Okay, since this is a DSA class, I should definitely go to the implementation first. Okay, and then I will go with the problems. Okay, I will let you know the implementation how it is written. Since the implementation is already there in the backend, you can directly go and see that implementation. But I will also let you know how the implementation is written, and then I will go with the problems over your linked list. Okay. So what operations we require first? So first we will see the insertion operation. Okay. First we will see the insertion operation, but before that we'll be creating our class, right? Your linked list, the node class we need to create first. Okay. So what I'll be doing, so suppose you are writing a class linked list. Okay, the class linked list I'm writing. So inside this class, I will take a inner class. Okay, inside this class, I will take a static class, inner class. Okay, static class, your node class, I will take it up. Okay, and then here I will be taking the data part. Okay, here I will be taking the data part, and then the address of the next node. Okay, the address of your next node. So basically node part as well. This is of node type. Okay, data part and then node type, and this is nothing but your inner class. Okay, and then this will be like I'll be taking the head node as well. Head node as well. Okay, so basically this head node I will be creating through your inner class. The head node will have, when you're creating the head node, what it should have basically, it should have your data part, it should have your next part, right? So like this you will be creating your inner class. Okay, within the linked list class. Okay, within the linked list class you can have your inner class. Are we clear until this point? Yes. Are we clear until this point? So when you are creating a node, you will have your constructor here as well. Okay. When you're creating this, when you're calling this class, okay, when you're calling this class, when you're calling this class, you will have your data part, you will have your next part. Okay. So Anurag, I doubt this is not a code. This is not a code. I'm writing down directly the code only, right? You will tell again, like pseudocode, how it will be, like pseudocode will be in English, like take linked list class. Okay, take linked list class, then take data, and take next fields. Like that, if I write it in English, that is called as a pseudocode. This is called as code only. If I run it in the editor, the it will run, right? I'm just writing it currently, and then I will write it in the editor. Why don't you open up your editor and write at the same time? Yeah, like while I'm explaining, you can write it down, right? Then after I will go to the editor, right? Okay. So into data and node next. So this dot data is equal to data, and this dot so this dot, like this dot data is equal to your data, and this dot next is equal to next. So this you will be initializing within this constructor. Okay. Yeah. So let me go to our editor itself directly.
It's 8 o'clock.
Okay, I will create another project. Linked list problems. Okay. Finish. Class. Linked list. A main class I will create. publish static void main. Okay. Then within this class, I am going to create the linked list class linked list. Okay. Then you will have your class. Okay. Then within this, I am going to create a static class, your node class. Okay. Your node class. And then I am going to take it the two fields within the what the node contains. It contains your data part. It contains your next part, right? The next part will be of next node. Okay, next node address. So it will be of type node itself. It will be of type node itself because this next part will point to the next point will point to the if I'm writing your int, what will happen? You can ask me. You can ask me the doubt. Why you are writing node, sir? You write int only, no, sir. You are storing the address, no, sir. You can ask. But what is happening here? What is happening? I am pointing this next to the next node. Not I am not doing out the address. Next object. I'm pointing out to the next object. So for that reason, I am going with the node itself. Okay, our node itself. Okay, so then I will have your constructor. So constructors, go to source, right click here in editor, you can right click and then you can directly generate the constructor from here. Generate constructor from fields. So I created the constructor here. Okay, public node into data node and then linked list dot node of next and then super and this dot data is equal to data, this dot next is equal to next. Okay, so this is nothing but your this is nothing but your constructor. Okay, then you will have your first node, right? That is add node within the linked list. I will take. So this is your linked list structure. Okay, linked list structure. Are we clear? Yes, are we clear? Okay. Yeah, I will explain that. I will explain that static. Let it be like that now. Let me explain it. Okay, in the main method, while I am creating the object, I was seeing your questions, Anurag. When I get time in the sense, when I have completed that, when I'm going to that particular topic, I know it. I know it. Like when the static question will come, basically, I'm writing static keyword here. So because keen observing students will definitely ask that question. I know it. But when I'm explaining this main class, when I'm creating the object of it, I will explain that static keyword. Okay. Just give me some time. Okay. So now I wanted to, what I need to do, first I will do the insertion operation. First I will be doing the insertion operation. Okay. So I'll be writing a method, public static. That insertion operation will return me the linked list itself, right? That insertion operation will be returning the linked list itself. So I'll be writing the linked list only, and then insert operation. Okay, insert operation. This insert operation will be taking the your node data. So basically, it should take the linked list, whole list. It should take. Okay, the whole list it should take, and it should take your data as well. Enter data. Enter data. What you need to add into the linked list that it should be taken. Okay. So for adding your data, what you need to do? So suppose the linked list is like this, right? So first one, if you wanted to add, what you'll be checking? First one, if you wanted to add, what you will do? Directly you can add it up, right? Directly you can add it up, right? New node of like if nothing is there inside your linked list. So what you will do now? New, okay, new node, new linked list dot node of 15. Directly you can add it up like this, right? Directly you can add it up like this. Then what will happen now? What will happen now? No node of 15 comma null you will pass. Okay, comma null you will pass, because you will pass the data part, you will pass your next part. Next part I'm passing it as null. Okay, I'm passing it as null. So what will happen now? You will have your data part as 15, the last part as null. Okay, then I wanted to insert the second node as well. What you will name this? You will name this as node head. Okay, you will name it as head. Okay, so this will be the head node. Now you wanted to add the next node. You wanted to add the next node. Again, you will create the object. Again, you will create the object how? New node, new linker list, new linker list. Okay, dot node of 16 comma 16 comma null. Okay, 16 comma null. You are again doing that. Okay, you are again doing that. Then what will happen now? It will create another object. It will create another object that is 16, and this will be null. Okay, now what you are doing, head dot next. Like what you need to do? What you need to do? You need to join this both. You need to join this both. How you will be joining it? Like you can take it as, you can take it as, like this will be some you can take it as some temp node. Okay, temp is equal to new node, you will take it up. Okay, so what you'll be doing, head dot next, head dot next, head dot next is equal to temp. Head dot next is equal to temp. Okay, you'll be joining up like this. You'll be joining up like this. Okay, so head dot next is equal to temp. Like this, you will join it up. Head dot next, head dot next. You are calling this pointer, next pointer. Okay, head dot next. That pointer you are calling. Okay, that pointer. Using that pointer, you are calling the temp. Okay, you are calling this. Then again, if you wanted to add new node, again you will create an object 17. Okay, this will be now temp. Okay, then what you will do, you will add again, like this will be some temp one or something you can take, and then temp dot next is equal to new node. Okay, so like this you will do the things. Okay, so let me clear my drawings. Okay, so if list dot head, okay, list dot head double equal to null. Okay, if it is double equal to null, or if it is double equal to null, when it is double equal to null, what you need to do, head is equal to, head is equal to, like basically you will do, like first you will create the new node. Okay, node, new node is equal to new node, new node dot new node of data. Okay, new node of data. Okay, there is only, you can create another constructor also if you wish to. Okay, you can, only data is required. No, this one is not required. Anyways, we'll be taking it as null only, right? Okay, anyways, we'll be taking it as null only for every node. So only one parameter is only okay. Okay, int of data. So this dot data is equal to data, and head is equal to, what you will do, if list dot head, list dot, okay, if list dot head double equal to null means it is empty. When it is empty, nothing is there, then what you will be doing, you will create the node, and what you will do, head is equal to new node. Head is equal to new node. Okay, head dot head is equal to new node. You will directly, since that is a it is equal, like you can pass the list itself. Okay, list dot it is equal to new node. Okay, so if list dot add, if list dot add if list dot add is null, what you are doing, list dot add is equal to new node. Directly you are putting the add at the new node. Okay, else if it is not, okay, if it is not, if it is not, what you need to do, you need to move the, like you should take, you like basically you should be like you should move the term, you should move the head, you will attach the head to the next pointer, right? So what you are doing there, so basically list dot add, right? No, like basically you can take it as next node. Okay, you can take it as some next node or temporary node. Okay, new next node is equal to like list, you can take it as add dot next. Okay, add dot, or else you can take it as list dot add itself. Okay, list dot add itself. Node next node is also list dot add itself. And then what you are doing, you need to traverse it. You need to traverse it. Okay, you need to traverse it. Where until where you will until where you will traverse. So basically, I am taking this as your okay. Next, while next node not equal to, like next node dot next. Okay, next node dot next not equal to null. Okay, not equal to null. What I need to do, if it is like until end, I should traverse until end, I should be traversing. And then what I'll be doing, next node dot next, next node dot next is equal to new. Okay, is equal to new node, and then I'll be returning that list. Okay, I'll be returning that list. Okay, I am taking a new node, and then if list dot add double equal to null, if it is the first node, okay, then what I am doing, list dot add, this list dot add is equal to, I am putting the new node. Else what I will do, I will take the, you can take it as temp only, that will be easier for you to read. So node temp is equal to list dot add, I am putting the add pointer. Okay, so here also temp. Okay, here also temp. Okay, temp dot next is equal to new node. So now you see, I will explain it once again. Suppose I'm calling the insert of 15, insert of 16, 17, 21, 25. Okay, so now what will happen, see, it will come inside. Okay, I'm giving the list, I'm giving the list reference in the sense that you can point to this. Okay, if you're giving the list reference, you can point to head. Okay, you can point to head, you can easily get the head reference. Okay, so for that reason I'm taking the list reference, the previous list reference. Okay, and then data part. Okay, now what you see, new node is equal to new node of data in the sense 15. Okay, now new node will be, this new node will be new node of 15, and this will be pointing to the null. And if you can see, node, okay, node, new node is equal to new node of data I'm calling, means this constructor I'm calling. So what will happen now, this dot data is equal to data, means data will be initialized to 15. Like next will be anyways null, because this is a reference type. So if you're not initializing the value, it will be by default null. Okay, this will also be null. This will also be null. So now you see if list.add, list.add in the sense, list.add in the sense, list.add, add in the sense this one. List.add, list.add is double equal to null. Then it should go inside, right? It is equal to null, it will go inside. List.add is equal to new node, means I am assigning add to this new node. So now this is our new node. What I am doing, I am assigning the add also here. I'm assigning the add also here. Okay, then it will not go to the else condition. It will directly return the list. Okay, so it will directly return this list. So now list is there like this. Okay, now list is there like this. Again, I am calling the insert function, that is 16. Again, it will come here and it will create a new node. It will create a new node. New node. Okay, new node of, this will be null. This will be 16. Okay, then list.add. List.add in the sense this list. List.add. List.add is what? List.add double equal to null. Is it double equal to null? No, it is pointing to this new node. Okay, it is not equal to, it is not double equal to null now. It will go to the else condition. Since this is failed, there is one element is there already in the list. So it will not go inside. It will go to the else condition. So no temp is equal to list.add. So what I am doing here, here I am attaching, temp as well. Okay, temp is equal to list.add. Okay, then while I need to find out the position, right? I need to find out the position where I should place, because I can place it at the tail node itself. After tail node, I can place. So I need to iterate over it. How many elements are there? I don't know. How many objects are there? Initially, I don't know. So for that reason, I will be using a while loop and I will iterate over it for traverse. Okay. While temp.next, not equal to null, then only you move. But here it is while temp.next not equal to null, but here it is not null, right? Okay, okay. So while temp.next not equal to null, then what you need to do, temp is equal to temp.next is equal to new node. So temp.next will be attached to the new node. Okay, temp.next will be attached to the new node. Okay, so like this, again 17 will be created. Okay, again 17 will be created. Again temp.next is equal to new node. So like this it will go on taking out the things from there. Okay, it will go on taking out the things from there. Then I stop here after 2 year temp.next is equal to okay. So basically here if you see, this is your temp node, right? This is your temp node. This is your head node as well. While temp.next is already null, so it will not go inside. Then what you should do, temp.next is equal to new node. Once you are traversing, this temp is for what? To traverse to the end of the list. To traverse to the end of the list. This temp is for traversing to the end of the list. Okay, until you traverse to the end of the list, then you after the tail you should be placing that object, right? You'll be placing that node. So for that reason, after the loop you should place it up. Okay, after the loop. This will not go to the infinite loop. It will go until null, until not equal to null. And when it is null, it will come out of the loop. And then it will be pointing to the next node. Okay. Okay, let me explain once again for your sake. Okay, so now I'm creating an object. Okay, so first node I wanted to insert, that is 15. So what will happen now? It will create a new node, right? It will create a new node. This new node, the data will be 10. This will be null. Okay, this will be null. So list dot add not double equal to null, because add is so here data is, so data initially next is null itself. Add is also null itself. Okay, it is also null itself. So what will happen now? What will happen now? List dot add double equal to null. So list dot add is equal to new node. List dot add is equal to new node. Okay, list dot add is equal to new node. So what will happen now? This will be the new node. This will be the new node. Okay, so then again it will not go to the else condition, and it will return the list. So now list will contains your head pointer, that is 10. Okay, then 15. Then if you wanted to add 15, it will again come. It will again come. Head is at 10 itself. Okay, it will again create a new node. It will again create a new node. So we are moving it from here. This will it will again create a new node with 15 and then null. Okay, now list dot add double equal to null. Condition is false because there is already one node is there. So it will go to the else block, and then the temp is equal to list dot add. So temp also will be here at the head pointer itself. While temp dot next not equal to null. So temp is at here itself. Temp dot next not equal to null. Temp is already null. Temp dot next is already null. Right? This is null already. So it will not go inside the while block. It will go to the this one. So temp dot next is equal to new node. So temp dot next. So this will be pointing to the new node. Okay, this is your new node, right? This will be pointing to the new node. Okay. Then again, if you wanted to add some 17, okay, then again it will come inside. It will create a new node with 17. Okay. Now you are returning the list. Returning the list in the sense you have just written the head node. That's it, with head. So it will be pointing to the list. So basically, what will happen now? You are removing this thing. Okay. Now, again, what will happen? You are returning until this point. These two nodes you are returning, right? In before case. Now, again, you are adding the new node, which is 17. It will come inside, it will add a new node, that is 17. This will be null. And then if list dot add double equal to null, list dot add is not equal to null. It is, there are some elements are there. Okay, so it will go to the else block. Node temp is equal to list dot add. Node temp is equal to list dot add. So this temp will be here. Okay, and then where you need to insert immediately, not you should not insert after the node, you should insert, right? After the, you should find out the tail node first, and then you should insert. So you will go to the while block. While temp dot next not equal to null, temp dot next not equal to null, it is not equal to null, so it will go inside. It will go inside. So temp is equal to temp dot next is equal to new node. Okay, so what will happen? See, again we have written error here. Temp is equal to temp dot next. So what will happen now? temp will be pointing to the temp dot next. Okay, this is not new node, it is temp. Okay, temp will be pointing to the temp dot next. So this will be temp. Okay, then again, while temp dot next not equal to null, temp dot next is already null. So it will come out of the loop, and then temp dot next is equal to new node. So this null will be moving off, and temp dot next is equal to new node, and now what will happen? You are returning the list. So the list contains 10, 15, and 17. Okay, then again, if you wanted to insert 18, you will again create a new node. 18, and then null. Okay, and then null. This will be your new node. Okay, this will be your new node. Then if list dot at double equal to null, list is not null. Okay, so it will go to the else block. It is already there. Okay, it will go to the else block. Node temp is equal to list dot at. So temp will be here. Okay, while temp dot next not equal to null, temp dot next is not equal to null. It is pointing to second element, right? So it will come inside. Temp is equal to temp dot next. We are moving the temp pointer here. Then again temp dot next is not equal to null. Then again we are moving the temp pointer here. Okay, we are again moving the temp pointer here. Then temp dot next is not equal to null. Condition is false, it is equal to null. So what will happen now? It will go to the 24th line, and it will temp dot next is equal to new node. Okay, it will point to the new node, and it will return this list. So like this, the insert operation will work. Okay, so can you take it down this one, the insert operation? The insert operation. Can you take it down this? So if you can see why I'm writing, yeah, I will explain that also, Anurag. Can you do it that by yourself? Is it possible? Inserting in the between. Like I will explain that also. Once I give the clarity on delete function, you can do it automatically that insertion also. Okay. I will go to that. We are just in the insert at the beginning, right? Just complete one by one operation will complete. Okay. So you have asked why static here, right? So if static is not there, see where you are getting error. Where you are getting error, you're getting at this point. What it is telling? Read it out. No enclosing instance of type linked list is accessible. Must qualify the allocation with enclosing instance, right? So this is an inner class. This is an inner class. Okay. So inner class, now when you're not when you're writing when you're not writing a static, it becomes a instance class. Okay, it becomes an instance class. So how to access this constructor, or how to create an object of this? In that case, what you need to do, you need to create an object of the linked list class. Okay, linked list class, and then you should be accessing the new node. You cannot directly access it. If it is not static, you cannot directly access it. Okay, we need to create object of linked list, and then you should access it. If it is static, you can directly access it. That is the difference. Okay. So new linked list dot no new node, like that you should access it. If it is static, that is not required. Okay, for that reason I mentioned it as static. Clear? Yes, that will become wrong if you are not declaring it as static. If you are accessing with class name, then it will be wrong. Like this also it is wrong only. Okay, linked list dot node, or you cannot access like this also. Suppose if you wanted to access like this also, linked list dot node like this, you cannot access like that also. Okay, You cannot access. If it is static, you can access. So static in the sense you can access directly also. You can access a class name also. Okay. Give me one moment. I will be back. Okay, is it done, guys? Executing this? Yes. Can you try printing out this linker list? Can you try printing out? Can you try printing out the linker list? In the meantime, while I write the code, you can print it out as well. Okay, I'll be taking the list reference itself. Okay, how you will be printing? So node head is equal to list dot head. Okay, so while head, I should be checking whether it is null, right? While head not equal to null. Okay, if it is not equal to null, I will print out the head as well. So otherwise you can take it as temp only. Temp also, and now temp is equal to head, while temp not equal to null. What you will be doing? We will print out the temp dot data. Temp dot data. Okay, temp dot data, and then you will iterate over it. Temp is equal to temp dot next. Temp dot next. Okay, I don't require, I just record void. Then you can print it up like this out. You can directly print it out this also. You can directly print temp. Okay, so this is how you'll be printing the list, and then in your main class you can call this linker list. So you'll be creating an object of or else you can directly create a note linker list. Obj is equal to new linker list. Okay, then obj dot insert of, you can pass the data. You need to pass the object of linker list. Okay, object of linker list, and then you'll be passing the data as well. Data is some 23, and that is the same, right? Yeah. This will return me list. Okay, I will pass multiple elements. 26, 29, then 30. So this also I will take it as void itself, because anyways we are making the same list. Okay, void only I'm taking it up. Then obj dot 23, 26, 29, 30, and then obj dot print list. Obj dot print list. Okay, so let me run this. Okay, it has been inserted successfully. You can write directly linked list only, that is also fine. Linked list dot insert, like that also can write. Okay, because the insert and print were static. Like that also, class name also you can call, or with object also you can call, and then you are passing that object here. Okay, then you are printing out the linked list. Okay, it is successfully giving the printer list. And say 23, 26, 29, and 30. 26, 29, and 30. Okay, so this is how the printing is happening. Can you execute this as well? The printing of the list. Can you try printing this? Let me know once done. Okay. Okay. So I hope it is done. Yes, printing of the linked list is done. Arshain, it is already in the portal. Like it is already in the chat, your attendance. Where are you pinging me? Okay, it's already there. Attendance in the chat. Okay. So this is how you will print the linked list. I hope it is execution is also done. Okay. Okay, I'm giving assignment for today. Like 3 assignments I'll be giving for today. Please try to complete it. So first assignment. So basically here I have told you how to insert at beginning, insert at the delete. So what you will do, you will delete. Okay. You will be deleting the head node. You'll be deleting basically the tail node. The first assignment is deleting the tail node. Okay. The second assignment is suppose suppose the linked list is like this. Okay. 15, 25, 30. Suppose the linked list is like this. Then you should suppose the user is passing 25 to delete. Okay. 25 to delete. How you should delete? So basically the 25 should be deleted, and then 15 and then 30 should be there at any position. If other than the head and tail, at any position it can be at head, it can be a tail also. Okay. Delete by data. Okay. Delete by data. This you will be doing it up. And then third one, suppose here I have told only to insert in the tail. Okay, insert in the tail only I have told you, right? Insert in the head or insert in the tail. You can try doing the insert in the middle as well. You can try doing the insert in the middle as well. Other than tail and head, I need you to insert in the middle as well. Okay, that is your third assignment. That is inserting in middle. Okay, these were the 3 assignments you should try to complete. Okay, 3 assignments. Okay, then if you can do, I will also share one another assignment, that is a reversing a linked list. Okay, this I will be giving it up tomorrow, or else I will explain in the class and then I will give it up. That's fine. Okay, these 3 assignments for today, that is deleting the tail node, delete by data, and insert in the middle. Okay, insert in the middle, delete by data, deleting the tail node. Are we clear? Are we clear with the assignments? Yes. Are we clear in the assignments? Yeah, code I will share it up. Okay, code I told you to execute it, right? You did not execute on your AD. Okay, I'm sharing it in everyone chat. Okay, I've shared it over the chat box, and okay, some errors are there. Okay, you can observe that code. Okay, Anurag has shared one error. I'm seeing it. Method insert in main dot linked list cannot be applied to the given types. See, if you are taking linked list class name as correct only or not, you see. Just compare my code. Okay. I suppose you are taking the linked list, that is there is a mistake in that, I guess. Or else you're missing. Okay, let me check your all errors. A linked class linked list. See, inside the class main you are writing. Inside the class main you are writing. Then you need to create an object of class main first. You need to create an object of class main, and then you create the object of linked list. New main dot new linked list. Like that it will work because you are writing an inner class. You are writing an inner class. Okay, you have written the linked list class inside main class. Then now you should create inside the main method new linked list dot new main dot new linked list, like that you create, then it will work. Okay, like that you create, then it will work. Public static linked list, correct. And this can be void. Here in the case of linked list, static linked list you are writing, right? There you keep it as void because we are changing the same list. We are not returning anything, we are changing the same list. Okay, then print list is fine. Print list is fine. Okay, print list is also fine. And then insert, where you are writing insert code is not shared. Okay, okay, like that you do, your errors will be resolved. Okay, so on that note, I will wind up the session here. Thank you so much, guys. We'll meet again tomorrow, and good night. Yeah, Sushmita, you, over to you.
Yeah, sure, sir. Thank you.
Yeah, thank you.
Yeah, so some are asking about the materials which is already uploaded in LMS dashboard. If you are not able to access the material, kindly drop a mail to edl@xlr.com. We will check your query and we will resolve it for sure. I'm just posting the mail ID on chat, that is edl@xlr.com. Okay, yeah. Thank you all. We'll meet again by tomorrow. Thank you for joining. Good night, everyone.